Hello everybody, welcome back to more on math. Today we're going to talk about Math 13-14 in Calculus. We're going to talk about Chapter 2, Section 2, the homeworks. And here's the first one. So, for the function g of x, graphed below, find the following limits and explain why they do not exist, or explain why they don't exist. Okay, so the first one. Limit of g of x as x approaches 2. Remember, this is important. A limit must exist if it has the same values as approaching the limit value from both sides. Positive and negative. So for limit of a function to exist, it has to have the same values if you approach the limit value from negative and from the positive side. Alright, so that's very important. Case in point, this first example. The limit as x approaches 2. As x approaches 2 from the left, it looks like it's approaching 2. From the right, it looks like it's approaching 0. So since both of those from both directions doesn't equal the same thing, that one doesn't exist. The next one, the limit of g of x as x approaches 3. So from the left, infinitely close, it's approaching 1. From the right, it's approaching 1. They're both the same. It's approaching 1. As x approaches 4. Remember, now here's another thing. The limit doesn't have to exist at that actual point. It just has to approach the same value. Notice in this graph, the value at 4 is 1. But if you're coming from the left side, all of these values looks like it's approaching 0. From the right side, same thing. It's going down further, further, further. It looks like it's approaching 0. So therefore the limit exists. The limit is what it looks like it's approaching. It looks like it's approaching the 0 value, not the actual value. And then the limit at x equals 3.5. 3.5. So from the left hand side, it looks like it's approaching 0.5. From the right hand side, 0.5. So that one exists, it's approaching 0.5. Number 2. Suppose that a function f of x is defined for all real numbers, real values of x in the closed interval -1, 1. Can anything be said about the existence of f of x at 0? Give the reason why. Okay, at x equals 0, f of x must exist because the function is defined at every point on the interval. That. Not necessarily true. Nothing can be said about the existence of the limit, even though the function is defined at every point in the interval. There may be a jump or oscillation. Exactly. That one looks like the best one so far. At x equals 0, f of x does not exist. No, that's not true, because if it's defined in all of them, then it has to exist. So the answer is B. This is an example. It's defined at all points, but it could have a jump, or the value and the limit could be two different things. All right, number 3. Find the limit as x approaches -1 for the function. So the first thing we always try is find the limit as x approaches -1. As x approaches -1, this is a linear equation, so every point has to exist, so just plug it in there. 11 times -1 plus 12. -11 plus 12 equals 1. Number 4. Okay, this is a rational function, so look at the denominator. The only value we cannot use is -1, but we're going to 4. So let's just plug it in there. 4 plus 9 over 4 plus 1, 13 over 5. That's the limit. Okay, this is going to be a quadratic equation because x times x minus x squared. So it's a continuous function. There's no x's that can't be used. So we're going to approach a -1. 5 times -1. 13 times -1 minus 5. -5. -13 minus 5. -13 minus 5, they're both negative. Leave the sign, add the two numbers. Negative and negative is a positive. 15 times 8 is 90, so the answer is 90. Okay, we have a rational equation. If we plug in the value, this is not a restricted value. So we'll just plug it in there, see what happens. I'll put it over here. So 2 plus 9, 2 squared plus 14 times 2 plus 45. 2 plus 9 is 11. 4 plus 28 plus 45. Okay, so $45 plus 4 is 49. 49 plus 28 is 77. That's one way. That's the answer. There's another way you could have done it. So this is our original equation. Typically, whenever you have polynomials, it usually helps to see if we can factor them. So both have an x. They're both the same signs. They're both plus. What times what is 45? When you add them, you get 14. 9 and 5. Now these cancel, so we have 1 over x plus 5. As we go to 2, 2 plus 5 is 1 over 7. So there are a couple ways you can do it. This is usually the safest way, factoring it out first. So this is 1 over 7. The next one. This is a prime example. But if we, the reason the second method works the best, because look at here's an example. If we put 20 in there, we get 20 minus 20 is 0. 20 squared is 400. Whenever you have a function that has 0 over 0, factor them out. So the top equation is x minus 20. The bottom number is a difference of 2 squares. It's x plus 20, x minus 20. So x minus 20's cancel. We got 1 over x plus 20. So now I can plug it in. If x goes to 20, we got 1 over 40. And that's the limit of this one, 1 over 40. So we put a 9 in there, get 81 minus 63 minus 18, 0 over 0. So let's see if we can factor it out. So we have x squared, 7x minus 18. Okay, so the top. They both have an x in common. Since the second sign's a minus, one of them has to be positive, one of them has to be negative. The bigger number is going to be a negative. So what times what is 18 when you subtract them, you get 7. 9 and 2. 9 times 2 is 18, 9 minus 2 is 7. So the bigger number 9 goes in the negative. So x minus 9 is canceled, leaving us with x plus 2. When x goes to 9, we get 11. That's the limit. Again, if we put negative 5 in there, it's positive 35 minus 35 is 0. Negative 125 plus 125. So we can factor them out. Let's see. So negative 7x minus 35. X cubed plus 5x squared. So we factor out a negative 7 out of the top. Take out a 7 out here, it leaves 5. We take out x squared with x plus 5. So we have negative 7 over x squared. So x goes to negative 5. negative 5 squared, negative 7 over 25. That's the limit. Alright, so far so good. Let's do the next page. Alright. Same thing. If we put 144 on the bottom, it's 0. Square root of 144 is 12. Now, in this type of equation, whenever you have radicals, you can't really factor this out. So what you have to do here is multiply top and bottom by the conjugate of the radical term. The conjugate is simply changes sign between the terms. So it's radical x minus 12 multiplied by radical x plus 12. Do it top and bottom. Because we're just multiplying by 1. We're not changing anything, just changing the way it looks. So, radical x is x plus 12 radical x minus 12 radical x. Positive times negative is negative. 12 times 12 is 144. Those cancel. On the bottom we still have this term. So since the 12's cancel, we have left x minus 144 on top divided by x minus 144 times radical x plus 12. X minus 44 is cancelled, leaving us with 1 over radical x plus 12. Remember, this is a dividing line. There's a times 1. So if you cancel these guys, there's always a 1 up on top. Now, we put 144 in there. So the square root of 144 is 12. 12 plus 12 is 24. So it's 1 over 24. Now the trig functions. The limit as x goes to 0. So we have 2 sine times 0 minus 1. Sine of 0 is 0. So it's 2 times 0 is minus 1. So the answer is negative 1. Secant. Secant is 1 over cosine. Remember, we have secant and cosecant. Secant is 1 over cosine. Cosecant is 1 over sine. Easiest way to remember it is you can't start with the same first letters. So cosecant cannot have a cosine on the bottom because they both have c's. Cosecant sine, secant cosine. Now, plug in 0. 1 over cosine 0. Cosine of 0 is 1. So it's 1 over 1. Remember, cosine of 0, this point here is 1 comma 0. The cosine and the sine at 0. Number 13. Find this limit. 4 plus 5x plus sine x. 5 cosine x. 4 plus at going to 0. 5 cosine 0. So 5 times 0 is 0. Cosine of 0 is 0. I mean, sine of 0 is 0. Cosine of 0 is 1. So we have 4 plus 0 plus 0. 5 times 1. 4 over 5. The last one for that one. Oh, got two. We got some more here. Number 4. Okay, this one. Suppose limit of f of x equals 1, g of x equals negative 7. Name the rules or limit laws. The rules or limit laws. Remember, there are like 7 or 8 of them. The sum, the difference, the quotient, the product. That accomplish the steps. So the first one, we take the limit and we separate them. So that's the quotient rule. We use these down here. Number 2. What I did here is limit because of the difference ones. I have on the top, I have the difference rule. And the bottom, I have the product rule because I have. So I have the difference rule and the power rule. And product power. But the exponent, I took this limit only of this function to that power. Okay, now what I do? Right, there's a 4. It comes out to the front. Okay, so that's the constant multiple rule, because I took out the constant multiple. So it's either this one or that one. And what else did I do? Oh, I separated the bottom. The limit of f(x) plus 7. So that's the sum rule. So it's the constant multiple rule plus the sum rule. So that one, yeah, just reference the rules in our notes. And the last one. I hope it's the last one, yeah. Yep, last 2. Alright. Suppose the limit of p of x is 9, r of x is 0, s of x is negative 4. Find the following limits. Because of the sum rule, I could have limit of p of x plus limit of r of x plus the limit of s of x. They're all going to do the same thing, negative 3. So this is 9 plus 0 plus negative 4, which is 5. So it's 9 minus 4. This is the product rule. So I have the limit of p of x times the limit of r of x times the limit of s of x. So it's 9 times 0 times negative 4 is 0. There's a whole bunch of them. We have a constant multiple, we have the sum rule. So the first thing we can do, we can split these up. X plus 2 r of x divided by limit of s of x. The top becomes the limit of negative 5p of x plus the limit of 2r of x over the limit of s of x. The constant multiples go out in front. Negative 5 limit p of x plus 2 limit r of x all over limit of s of x. Limit p of x is 9. Limit of r of x is 0. And limit of s of x is negative 4. So that's gone. So we have negative 45 over negative 4. That cancels. 45 over 4. Alright, then the last one. If radical 10 minus 7x squared is less than or equal to f of x less than or equal to 10 radical 10 minus x squared for the interval negative 1 to 1, find the limit of f of x equals 0 at 0. This is the squeeze theorem. The squeeze theorem says if you have two functions, or you have a function that's greater than or equal to one function, that's the first one, and less than or equal to the second one, and if they're equal, if f of x, if the ends are equal, the same values, then that means the middle term has to be the same. So if this is 1 and that's 1, then f of x has to be 1. So let's see. So we do it as at x equals 0. So we have 10 minus 7 times 0 squared, f of x, radical 10 minus 0 squared, that's 0, that's 0, so radical 10. So the only thing that tells us then is limit, as I said, equals radical 10. Because it's the squeeze theorem. Alright, good luck everybody. See you in the next section.